Hello and welcome to SPSS Class 3 from Part S25. We're looking at simple bar charts. So we just go to the graph builder here, chart builder, sorry, and we select from all these options here just a simple bar chart like that. And then you can select all of these variables except for the observation number because it doesn't make sense to put that on. Everything else you can just drag into here. And it gives you a warning saying, oh, you've dragged a lot of stuff, but just say okay to that. Okay to that. And okay should produce the chart with the luck. There's the output, there's an Africa map, there we go. So, to answer the questions here, question 4 here. So, on average, which of these management systems seems to be best for bird diversity? Well, fairly obviously it seems to be the selection system. And when that means when you cut down just selected trees, that has a rating of nearly 2. And 2 means that compared to not having this management system, it's doubling diversity. So it's much better than not having a management system at all. It's doubling it. These ones around 1, that's not making much difference. The ones below 1, this means that all these logging systems here are having a negative impact. It's lower than what you'd expect in other situations. But to answer the question 2, select is the best one, virtually doubling the bird diversity. Retention system or reduced impact selective logging, that's the next 2. So it seems to be here in the sample, it's slightly higher with selective reduced impact than it is with retention. And fuel wood seems to be slightly better than the slash and burn, which is almost the worst, apart from the plantations and non-timber products, which means like completely slashing and putting stuff that isn't even trees in there. So those are the worst. But it seems that this one, plantation with fuel, is slightly better than slash and burn at the moment, according to that. Okay, so that's question 4. Let's have a look at S26 doing the same thing, but this time we're going to do error bar instead. So go back to the same steps. This time put on an error bar. You have to select the variables again, interestingly, even though it's kept them on the preview window. Should give you a warning, hopefully. Let's give the warning something. Okay, great, let's see if it will do it. Output array. Yeah, so it's done that there. Okay, so you can see how the results sort of compare, similar patterns to this, but how they compare with the results in the article. So you need to have the article from the reading list here. And the main presentation really of results is that we're comparing with is here, figure 1. So we look at the thing for birds here, just focusing on that birds one. Space. So you can see here's the birds one. That's pretty. Oops, unless we hide it completely. It seems to be not a million miles away from what we've found. It's hard to get them both visible for you on the screen to compare, but hopefully you can compare it side by side. There's my output. Yeah, so selection is this one. They're in the same order. Yeah, so very similar kind of pattern. Those two kind of don't have a lot of effect. This one's a bit worse, and then these ones are the worst ones down here. Since you're really putting down. So broadly speaking, they're quite comparable, and also the size of these things as well, which we'll come to later. The size, the spreads here is smaller compared to that huge on the left, which is bigger on ours as well. So broadly speaking, we're getting the same kind of levels and the same variation in our data as they did in the article. Okay, so if we just use Explore to do this, so S27, just remind you this wonderful command, Explore. Just gives you basic statistics and just again selects everything except not observation because that's not a meaningful variable. So put all those in there. Leave factor so it won't try and split it up, but just give you the stats for each variable overall without any subdivisions. You don't want any plots really, so just go for stats. Because it's going to give you masses and masses of output. But hopefully you can see how this, so have a look at this. Can you see how this, which bits of this relate to these graphs? So have a think and pause the video. This is question 6 we're on now. So if you paused it, hopefully you've thought about it. Under the selection method, what's the mean species diversity impact is 1.9642. So that's the 1.9642, and similar for the other ones. Like for retention, it's 1. Select for retention about 1, and so on. So that's these dots are the means. But these bits here come from here, the confidence interval. So about 1.39, 1.4 up to 2.5. That's this 1.4 up to 2.5. Next one down is 0.8 up to 1.18. 0.8 up to, that's that there. So what the error bars are showing you is what's called the 95% confidence interval. And if you've done the asynchronous work, you'll see that that's in there as well. So it's error bars are a diagram of the mean plus the confidence interval. And you can work it out exactly from Explore using the statistics option there, if you want to calculate what they actually are. So that's the answer to S6. And then let's just do this part, it's extremely quick. Just do the error bars for the other ones. Arthropod and plant species diversity. In fact, sorry, it's 6 minutes long, so I'll do it in the next video. So thank you for watching.